Okay. All right. Thank you very much, Dr. Eeydzah, for us to have you this morning. Okay. Dr. Eeydzah is a senior lecturer from SKA or from UTM. Okay. She is currently having the practical industrial trainings at JKR, Kuala Lumpur. Okay. If you are free, you can look for her over there. Just kidding. Okay. But she is very experienced and is very actively participate in the sustainable project. Okay, for example, IBS project, BIM projects, and sustainable materials, and so forth. Okay, so these are the fields that Dr. Eeydzah actively participated. Hence, Dr. Eeydzah, this morning, she's going to give us the topic on improving thermal performance of buildings from waste to wealth. Okay, so without further ado, let us invite Dr. Eeydzah to start the input lecture for today. Thank you very much, Dr. Eeydzah.
All right. First of all, thank you so much, Dr. PC, for inviting me. I feel very honored.
Thank you.
Thank you so much. Hi guys. I hope you guys can always interact me. Okay, since I think because I already undergo sabbatical, so for this couple of months, I've not been lecturing. So, but I do hope. But some of them did call me for special invitation online. Lecture. So I do hope you guys can interact me. Okay. Please. All right. So a bit description about myself. Like what Dr. PC already introduced. Just sharing. Okay. I'm currently the senior lecturer in School of Civil Engineering. This is my 5th year in UTM. And previously, have you ever heard about last week we just launched Malaysian Construction 4.0. Is there anyone alert about that? Can anyone say that? Ada tak siapa-siapa? Did you guys listen that there is a strategic plan for our construction industry?
Anyone, students? Or if you shy, you can type at the chat box also.
Yeah, please interact. I want everyone to please interact me. Ada tak? Ada dengar tak? Have you ever realized that we just launched Construction 4.0? No?
No.
It's okay. All right. So I'm gonna touch a bit on our strategic plan, construction industry plan, and also I'm currently the MICRES qualified professional under CIDB. Did any one of you knows what is MICRES? Ini nak kena panggil seseorang ni. Arifah?
Please.
Did you know about MICRES?
MICRES tak familiar. Saya familiar lah CIDB, MICRES tak.
Okay, right. It's actually a green tools. Belinda, maybe Belinda Leong? No?
Segan semua.
How about Intan Rahayu? Have you ever heard about MICRES? No as well. Okay. All right. So guys, you're lucky because I'm gonna touch not much, but just give you guys a brief what is actually MICRES. So MICRES is actually a green building tools. Like last time kita ada GPI, like Dr. PC, you are qualified under Japanese
CASB.
CASB, right? So we have leads. So this is all the green rating tools that are available in our national, but it depends. Okay, like MICRES, for every 50 million project, it is a requirement for them to submit MICRES. It's actually Malaysian carbon reduction for sustainability. So basically, you have to have all the rating tools that inside the requirement, it requires you to submit what is the sustainable, in terms of OTTV, what is the value of OTTV, what kind of materials that you use for your construction. So that's where comes to this topic, which is on thermal performance, because it really clearly defines the national agenda towards sustainability. Okay, and then I'm also certified energy manager under EMAS. So basically, for our country, it is compulsory. It's not compulsory, but it's a part of requirement to submit our energy capacity, energy building performance, to evaluate what is actually the current consumption for the building operation during operation. So it's very important for us to submit this because it can educate our country what is actually our carbon emission performance as whole. So that's why for me, as a sustainable person, I need to know what is the sustainable tools, and at the same time, I need to know the energy management so that I can understand, I can undergo what kind of research that is linked, because sustainability, energy management is all linked when we talk about and sustainable. And coming into current situation, we are talking about beam. Beam pun, if you can see, there is an element in terms of 7D, 8D, whereby in 7D, they are looking into the performance of sustainability. So later I'm going to show a bit. I'm sure all of you knows what is actually beam. And then we have this 70 that can fit in the sustainability in building formation modeling. Okay, so I like to have this. If you guys are really keen to it, sustainable, do join a part of this program. The national program to become a qualified professional for Micros. Okay, to become an energy manager, and also currently we are looking into Beam. So when we talk about building formation modeling, the platform is quite huge. It's quite big for current practitioner. Of course, you guys to be part of the team. Okay, sorry. I think I want to just log out from the WhatsApp because it keep on appear ganggu pula. Okay, sorry. Okay. So, okay, sorry guys. Can you see this? Okay. All right.
Yes.
So, okay, when I talk about thermal performance for building, guys, tell me. I want interaction. Okay, siapa pula? Okay, when I talk about Sustainable Development Goal, SDG, and I talk about what I'm going to give a lecture, which is on thermal performance, what do you think? Well, guess, okay, 3 goals that very close to the topic that I'm going to present today. Just shoot any goals. Ada 3 actually major contribution that we are looking towards SDG for today. So anyone can give a wild guess? SDG number berapa sebenarnya yang fits for today's lecture? Go on.
Belinda said number 11.
Number
Kwa said
11.
12.
Okay, correct. 12.
Kwa said 12.
7,
Nas.
11, 12. 7, 11, 12. Okay. Siapa lagi? Number 3. Okay. Who else? Arniza, 7, 12 dengan 9. 7, 12 dengan 9. Okay. Alright. Okay, kalau dekat office, kalau kita buat kat kelas, saya dah bagi you guys voucher Zalora ke? No. Okay, Interahayu 3, 7 and 11. Okay, alright, quite interesting. But when I go through, okay, it is quite close to number 11, of course, sustainable cities, okay, and communities. Okay, it quite close to number 9 and also number 13. So 9, 11 and 13 is very close towards what I'm going to present for today. Okay, why 9? Because we try to embed what is the current technology for our infrastructure. Okay, and I will look into the number 11 because when we talk about try to reduce the thermal comfort, we are actually protecting the climate action, which is number 13, and also number 11, whereby we are trying to reduce the urban heat phenomenon in our society. So again, it's number 9, 11, and 13. Okay, but it's good guess for you guys. But then again, for what I'm going to present for today is much more close to number 9, 11, and 13. Okay, so just want to give a brief background about myself again. Okay, I started actually as a part-time lecturer back in 2013 in UTHM, and in 2014, while I'm doing my PhD, I'll become the consultant. I'll work as CNS consultant as a normal engineer, and then because I'm a direct student, I mean, I don't have master's degree towards PhD. So during my part-time lecture, 2013, UTHM request me to, hey, why don't you go for a normal interview for a senior lecturer? So I undergo for the interview, and during that time, they offered me straight away with senior lecturer, which is the S51 during the interview 2013. But in condition, because I don't have master's program, I don't have master's degree, and they said you must submit at least Senate. You must give us Senate letter in order for you to become a lecturer. So back in 2013, I undergo the interview, and they just offered me straight away with the S51 as a lecturer. But I have to give them finish in terms of my PhD, the Senate letter from PhD. So straight after I finished my Viva, I got the Senate letter. Belum lagi grad, I become already a lecturer in UTHM. So then after that, I go to UTM, okay, and currently I'm undergo the sabbatical in JKR, and I've been supervised under engineer Ridwan, okay. He's also I can say a BIM practitioner in our national industry, and together with us inside the lecture, sorry Dr. PC, I invited engineer Kotrunada is also
No problem.
my mentor here in JKR, so she teach me a lot in terms of design. So thank you. Engineer Kotrun also is here, so you guys can just interact if you guys want to ask something on, because she's an expert in civil design. So okay, currently, okay, if you can see, this is my previous project. I have several projects together with also Dr. PC. We have projects like this one. Currently, I'm developing the Malaysian Green Rural Road Index. This is under project Prof. Rosanna. And also last time, back in 2 years' time, 2017, I undergo research on AR, mainly for BIM. And currently, I'm one of the team for web-based. Currently, what we are doing is the carbon calculator for MyJHI, Malaysian Green Highway Index, under Lembaga Liberai Malaysia. Okay, so like I mentioned last week, we just launched Construction 4.0 strategic plan. I'm one of the technical team with Malaysian Construction, with CIDB, to CREAM CIDB, to develop construction strategic plan. Okay, a part of my program with all the industry. So, and currently, if you can look into, we are moved towards AI, artificial intelligence, and also BIM. So this is what currently I did for my study. Okay, so that is a bit background on my about myself, and now we're going to focus again back in our, okay, tadi dah cerita pasal SDG, tiba-tiba cerita balik pasal kita punya background pula. I'm so sorry. Okay, so coming back to the SDG just now, okay, if you can see, it is number 9, 11, and number 13 on the climate change. Okay, looking towards the aspect of aerated concrete. Why this is actually my PhD topic. Okay, I choose this because I think it's very close to architecture students. Because I want to share with you guys the behavior of the aerated concrete. Have you ever heard about aerated concrete? Any one of you? When it comes to design, of course, a part of you, yes, right? You're going to use aerated concrete as a part of for the building materials. So aerated concrete, okay, why most of the construction they choose aerated concrete because it has lots of very good benefit aspect, especially in thermal insulation. Okay, why? Because of course our country is quite hot, humid, and we choose insulation material to just capture the heat from the outside, from coming to the inside. So that's why we try to have this thermal insulation property in aerated concrete. But for my PhD topic, my research, okay, no longer use the usage of sand, okay, instead of just normal aerated concrete. It is the material is actually sand and also aluminium, okay, with cement. So the integration of this aluminium and cement, it will later I'm going to show you the performance of how the whole, I can say it's like a foamy type were developed in aerated concrete. So but then again, I'll try to mix around, and we are no longer using sand, but instead of that, we are using bottom ash. So then again, that's why this topic is more on agro-industrial waste, whereby we are no longer use sand. Instead of that, we are using bottom ash. So bottom ash currently is act as a waste. Okay, kalau kita tengok, it has been dumped at landfill, especially in our thermal electric power generation. Okay, kalau you tengok, is quite a lot. It's abundant of this bottom ash produces from energy power plant. Sebab kita punya energy is being generated by coal kan. Kita kan pakai coal to generate our energy, electricity, and then this coal actually producing byproduct, which is act as bottom ash lah. The byproduct, kalau you pergi kat site, kalau kita boleh pergi kat site kan, you boleh tengok coal ni dia ada top ash and bottom ash. So bottom ash is the one that we're going to use because the burn, okay, bila coal ni dia burn untuk produce energy, some of the byproduct bottom ash ni dia jatuh dekat bawah, and the one yang jatuh ni banyak sebab bila pembakaran berlaku tak lengkap, dia akan jatuh dan akan jadi macam batu. So this bottom ash act quite the same as sand. Okay, dia punya property of sand dengan bottom ash ni sama. Cuma bottom ash ni is a bit lighter, and kalau you tengok dia hollow. So the surface itself also is very hollow, and that's why when we talk about specific gravity, okay, kalau kita tengok the material property, the specific gravity of bottom ash is quite lighter compared to sand. Sand ni lebih berat sebab pembakaran yang berlaku untuk bottom ash is uneven, dia tak lengkap, dan sebab tu dia akan produce hollow core. So that's the reason why specific gravity of bottom ash is lighter compared to sand. But the properties is the same. So bila kita tengok comparison bottom ash dengan sand ni, dia mempunyai alumina dengan silika yang about the same. So that's the reason why I try to change instead of using sand with bottom ash. And later I'm going to show why. I'm going to show to you guys kenapa we said bottom ash and sand is the same. Okay. So during the study, okay, I also collaborate with Nagoya Institute Technology. So my co-supervisor is Prof. Kenzo from Japan, Nagoya Institute Technology. So he also is one of the technical expert for asset construction. There's one company in Tajimi Tajimi ni kalau kita tengok kat Japan, dia is the hottest place. Dan tapi kalau kita pergi kat Tajimi tu, kita rasa sejuk. Sebab all the materials, okay, Sensei, Prof Kenzo, dia work out with asset construction dengan dia punya Datuk Bandar lah, kira Datuk Bandar dekat Tajimi, they come up with solution whereby kalau you pergi dekat that Tajimi area, you rasa sejuk. Sebab pavement dia tukar cool pavement, material perumahan construction material, so dia tukar jadi sejuk. Even dia punya atap pun dia sejuk, so that's why even dikatakan kalau kita tengok dia punya area tu dikatakan the hottest place, but still Tajimi tu sejuk sebab diorang ada buat so many research to come up with a very, in order for them to cool down the urban heat island that occur dekat Tajimi. So I think he's the best. Even though dia punya background is not an architect, he's also not a civil engineer. He's actually a medical doctor, but because of dia punya orang Jepun ni, dia suka explore so many things, and they find out that sebab dia pun currently medical doctor and also in agriculture, and also dia pun pernah kerja dekat power plant. Dia rasa benda ni is very important untuk dia fokus on how to overcome urban heat. So currently dekat Japan, dia one of the kiranya expert in reducing the urban impact on urban heat island in Japan. Okay, when I developed this product, I can say that our product is actually thermal insulation. Okay, it's a lightweight. Kalau kita kata lightweight tu, it must have berat kita punya material should be less than 1,800 kilogram per meter cube. Okay, that is the definition of lightweight. It's breathable. Okay, later I'm going to show you why I mentioned it's breathable. It's green product since we are using waste material, so it is kind of green product. Economical because it is waste. So we and then some more, aerated concrete ni sebenarnya dia pakai generated by high steam. Okay, tapi bila kita kata my product, I'm not using high steam. So bila kita tak guna high steam, it means that it save cost. But then again, of course lah, dia ada drawback sikit. Kalau high steam ni, kalau you tengok aerated concrete yang secara commercialized, dia punya bubble yang created is very even. Dia sama je rata. Tapi kalau kita tak pakai high steam, okay, macam yang saya, kita just bancuh normal without high steam, dia ada uneven pour. Tapi the performance is still there. Maknanya performance dia still bagus. What I mean by performance, later I'm going to show back to you. Okay. So again, I think we skip back, okay, sustainable. Sebab I just want to touch in, okay, kenapa as a researcher, okay, as a student, bila you come out into master's program macam ni, you always have to think sustainability is because kita punya agenda, our national agenda also is focusing towards environmental sustainable. So if you have an efficient product, a very good product, try to link back with our national agenda. Sebab it's very good because what you did is actually aligned with what national agenda is focusing. All right. And then when we talk about back to our national agenda, sebenarnya they try to reduce the waste. So what I'm trying to do now is actually to combine the idea of bringing the waste into the sustainable initiative. And a part of it, of course, I try to reduce the carbon emission. So cradle to, I can say my research is more on cradle to cradle, but then kita tak create end product towards waste, tapi instead of that, we use the waste to generate back into a new product that can be used as a benefit product. Okay. of course, kenapa again kita tengok into the phenomenon of climate change is because kita risau kenapa why the material that we develop must focus on the climate change issue, because we try to overcome. Okay, kita try to cut off the emissions so that kita tak rasa, we are not contributing towards CO2. That's the reason why as a researcher, as an engineer, as an architect, you guys have to always think about how to overcome the climate change issue. Okay, so coming back towards our the thing that we try to bring up for today. Okay, kalau kita tengok global warming, okay, the urban heat island issue, okay, when it has a high solar radiation, okay, this solar radiation they're gonna penetrate into a building. Okay, so of course I know all of you are very you guys tahu dah pasal what does it mean by microclimate, what does it mean by warmer and cooler. Okay, so kalau kita tengok bila kita ada banyak pokok, okay, all this pokok we're gonna absorb the CO2. Okay, but at the same time kita dah tak boleh nak elak. Okay, in our normal building, of course, when the heat penetrate, all the materials started to absorb. Okay, so the phenomenon that happened here, heat going to penetrate into heat going to transfer to our material, and heat conduction, some of it going to absorb in, and some of it gonna reflect. It depends on what kind of material that we use, but most of the material is going to start to absorb. And the byproduct, for example, bila kita jalan dekat building tu kan ada exhaust daripada kereta. Okay, they're going to create a waste heat, anthropogenic heat, yang akan menyebabkan heat surrounding tu lagi panas. So you bayangkan bila building tu dah started to absorb the heat, okay, some of the heat dia masuk kat dalam, some of it dia akan release keluar. Ada yang dia tak naik ke atas, so dia akan still stay dekat sebelah kita. That's why bila kita jalan sebelah bangunan, if the building it has a very high reflectance, some of it kita akan rasa panas sebab we are looking into our UV-Vis NMR. Kita tengok kepada wavelength of heat. That is another story. Okay, bila kita tengok wavelength of heat ni sendiri, kalau UV dia akan panas balik kat kita. Kita akan rasa. That's why kalau you tengok baju-baju, dia kata UV protection sebab dia nak make sure dia reflect back. Tapi dia tak perasan bila reflect kena balik dekat human. So that's the reason why we have to think not only on the UV protection, sebab wavelength ni dia ada UV, Vis, NMR. So bila NMR tu kita dah nampak nano, kita dah tak boleh rasa yang sebenarnya heat termasuk kat kita. Tapi tiba-tiba kita rasa demam. That is what how the behavior of heat transfer. But then again, we have to think of what kind of material actually can reflect and kind of, sebab kita kena terima that heat surrounding, there is still a heat. But then how the behavior of heat ni release cepat, dia boleh hilang cepat ke atas, that is the one that we have to study. So that's why my research is focusing on material that I try to develop mana satu material yang sebenarnya serap haba cepat, release haba cepat. So you know, it's quite a long process because we have to know that material kat dunia ni ada macam-macam, and the material ni it has their own different behavior. Macam human lah, kita manusia pun ada macam-macam behavior, sama juga dengan material. So material ni pun dia ada macam-macam behavior. So that's the reason why you know, when we want to start off with doing research, we have to know what is the effect. Okay, so you know, when I started to come up with the research, I tried to focus will the material that we're going to develop can actually overcome, have the evaporating cooling? Does the material have high in heat absorption? Okay, So can produce a lot of heat waves. So these are the things that we have to think of in order for us to overcome the urban heat island issue. So kalau kita tengok macam tadilah yang saya mention, okay, bila ada lots of building, kita akan produce lot of heat, okay, waste heat. So that comes from cars, okay. Albedo pun very important, okay. Sebab tu macam kita pergi kat Japan, okay, most of the Japan they try to have high in albedo. So kalau macam warna putih tu satu, kita tengok albedo kita, but actually it's not good sebab putih ni dia akan sakit mata, tapi sebenarnya dia bagus in terms of dia tak absorb heat yang terlalu banyak. So that's the reason why we have to know how to play around in between albedo, in between the heat performance, in between our solar reflectors. Sebab solar radiation ni pun dia ada pelbagai value. It depends on our peak sun. Okay, later I'm going to show you what does it mean by heat solar radiation. So far semua orang okay tak? Boleh ikut tak? Are you guys okay? Can? Okay. Do you guys understand what I'm my lecture for today? Okay. Boleh can follow because it's a bit very technical since I'm civil engineer, so we have to dig in why this thing happened. So if you guys have questions, just interact me along the way, okay? All right, so this is the relationship between surface and ambient temperature. So kalau kita tengok, if you can see here, okay, during the hot and humid, okay, especially during the midday, when the high solar reflectance, okay, kalau kita tengok sebenarnya cuba teka. Okay, I want you guys to give an idea. In between 12 to 4 o'clock. Okay. Sebenarnya, bila in our tropical climate, what is actually the peakest hot, I mean the most peak of the solar radiation? Can anyone guess? In between pukul 12 sampai pukul 4 lah. Sebenarnya pukul berapa? Actually, at what time is the hottest based on our tropical climate? 3. Okay. 1. Satu. Okay. Dah? That's the best you guys can give? 1, 3. Okay. Let me show you. Banyak lagi ni lecture ni. Okay, tak apa. Kita cuba cut it short. Okay, actually it is, alamak, tertukar pula. Okay, I want to show you it's actually in between 1:45, okay, to, green, red. Okay, kalau kita tengok kat sini, it's actually between 1:45 to, roughly the peakest is about 3:30 macam tu. Can see here? Okay, so this is actually the peakest time lah. I mean, it's about 2:45. Nampak tak? Dia punya peak. So this is actually our peakest point in our tropical climate. So jangan keluar lah. In between 2:45 roughly kan. Start pukul 1:45 ni sampai pukul 3:04 ni is actually the peakest point of our tropical climate. Okay. So betul lah tu, pukul 1, pukul 3 tu betul lah. Sebab this is actually the peakest hour, peakest point. Okay, nanti I'll show you the solar radiation later on. Okay, dia actually based on solar radiation lah, sebab kita akan tengok our solar radiation. Okay, I'm gonna show you later on. Alright, so far can follow So sebab tu it's quite dangerous lah if we go out in between 1 o'clock to 4 o'clock tu, kita boleh terkena heat stroke. That's why it's very important for you to know the peakest point. And normally my student kan, kalau dekat construction industry, a lot of my students, especially yang dekat PNB ni, diorang memang banyak yang kena heat stroke. Sebab the higher altitude you go, the higher tendency of heat stroke that you guys gonna face. So it's very important for you to know which exactly time. Kalau waktu hujan is okay, but if it's hot tropical peak hour, it's not good for your health. So try to know, okay, you know already 1:45, so boleh tapi you kena berjaga-jaga lah, minum lots of water, okay, so that you can know that heat stroke will not occur at your body, right? So okay, for my research, basically what I'm doing is that I try to get an idea what is actually the external wall surface temperature and the internal wall surface temperature in terms of aerated concrete. So looking back on the conceptual idea on how the heat transfer is actually, okay, kalau kita tengok solar radiation, panas matahari, okay, the sunlight, they have this solar radiation, and this solar radiation gonna radiate at our surface of any material. Okay, we're talking about building. Okay, sekarang ni I'm talking about building, and the radiation, okay, it will increase dekat surface temperature. In order for you to develop, to think of what is actually the suitable material, is to have the one that have a very less in terms of heat flux. Okay, kita nak thermal mass that has a very less thermal mass, because kenapa kita nak material yang absorb rendah dekat dalam material, so that material yang, sebab every material memang akan absorb heat. Okay, tapi material yang absorb the less is better, sebab dia tak akan simpan the heat flux dekat dalam, the thermal mass. So in order for you to do a research is to have a very less in terms of thermal mass, and basically we are looking into the very low thermal conductivity. Sebab lagi rendah thermal conductivity, the better in terms of thermal insulation. So that is the idea, to have a very low thermal conductivity, but at the same time it can has a very less thermal mass, sebab kita tak nak heat simpan dekat dalam kita punya building. But of course they're gonna keep in, but some of the material is gonna release cepat. So the good thing about the material that I produce is that dia simpan haba sekejap, dan dia release haba pun cepat. So maknanya nanti I'll show you, okay, pukul 6 tu dia dah start to release the heat dalam material, sebab of course semua building dia akan serap haba, tapi yang mana yang lepas haba cepat, itulah yang very good. That's why if you can see for the low cost house, okay, normally they are using sand brick. Okay, kejap lagi I'm going to show you another penemuan yang saya dapat daripada research ni, adalah penggunaan pasir sebenarnya tak bagus, sebab pasir ni dia punya thermal capacitance dia, okay, tinggi. So bila thermal capacitance dia tinggi, dia dia panas, dan dia simpan haba tu lama dekat dalam material, dia start to release back pun malam. So especially bila hujan, you pakai batu sand brick, that's why when it's raining, you use your sand brick, you feel macam a bit warm dekat dalam rumah. This is the reason, because sand tu disimpan haba dekat dalam material tu lama as compared to bottom ash. So I'm going to show you later on. Okay, so again, this is actually the heat transfer process. Okay, bila kita kata kat luar ni, okay, ni contoh ni dekat bahagian luar, sini bahagian dalam, okay, solar radiation dia transmit dekat kita punya bangunan. Okay, depends, ada yang long wave, ada yang short wave. Okay, kalau long wave dia akan keluar, ada yang reflected, dia akan keluar. Okay, dia pantau dekat material, dia pantau balik lah. Maknanya kalau when the solar entered to our material, part of it going to radiate, reflect back. Okay, so it depends. Some of the heat, that's why some of the heat they akan transfer. So that's the reason why we have to study in terms of the material performance. So antara dia, macam I mentioned just now, thermal mass and also thermal conductivity. That is the main yang kita boleh nampak secara material lah, yang kita boleh buat terus study, kita boleh test terus, adalah thermal conductivity dengan thermal mass. So from there we can actually identify lah the potential of this material, is it good or not. Okay. So adalah beberapa equation that we have to calculate in terms of calculating the heat convection. Okay, this is convection. We have to know the K convect, and then the area, the surface, and also ambient temperature. So there's a few equation lah untuk kita kira the heat tu sendiri. Okay. So, like I mentioned, kita ada, kalau kita tengok dulu, brick wall kan, dulu kan kita pakai clay brick, it actually has the highest thermal total heat, kalau you tengok kat sini. So, sebenarnya tak bagus lah. Sebab tu orang kalau you tengok banyak bangunan pakai granite, pakai tiles, but as a surface, because dia reflect the heat even better. Dia tak simpan haba. Compared to orang pakai brick wall, dia akan heat transfer tu dia akan simpan je kat dalam material. Okay. Okay. So, looking back into our aerated concrete, okay, normally normal aerated concrete dia punya density is ranging in between 400 to 900. Like I mentioned just now, when we talk about lightweight concrete, it must ranging in between less than 1008. So apa-apa material which is less than 1008, it is considered as lightweight. Okay. And the properties of normal aerated concrete, kalau you tengok kan, dia small pores and dia very even. Compared to this is my brick. Okay, dia uneven. Tapi kita tak guna high steam. Sebab kalau you tengok kat atas ni, normal aerated concrete, dia memang pakai high steam. That's why dia mahal, tapi tadi kan kita nak cakap, kita nak try to cut cost, kita tak nak guna energy, high energy. That's the reason why I try to reduce. But dia adalah drawback sikit sebab dia uneven pores yang terbentuk. Okay, so kalau kita tengok, konsep aerated concrete sebenarnya dia ada alumina. Tadi kan yang cakap dia pakai aluminium. Dia pakai simen dengan air. Lepas tu high steam. So dia akan develop calcium oxide alumina yang akan membentuk ettringite. Ettringite ni macam itulah dia punya strength dekat konkrit tu. Nanti I can show you guys later what is the mean by ettringite lah. So ettringite ni sebenarnya yang membuatkan aerated concrete tu kuat. Dia punya pembentukan. Sebab sebagai civil engineer, you need to know how the development, the properties of sand and cement, macam mana dia bentuk kekuatan tu. So kalau macam normal, kita panggil heat of hydration kalau normal concrete. Okay, kalau kita tengok concrete terbentuk kalsium campur air, campur pasir, dia akan bentuk calcium silicate hydride. So that is normal heat of hydration. Tapi dalam sistem aerated concrete, dia lebih kepada ettringite. I'm so sorry, it's a bit technical, but this is actually how it develops. Okay, so what I'm doing actually, just now saya mentioned bottom ash, I replace with, sand I replace with bottom ash, and actually cement, I no longer use cement, but instead of that, using fly ash. So fly ash also, it has the same property as cement. Okay, so that was the thing that I did. Okay, and then kalau kita tengok previous study, sebenarnya dah orang buat 2009. Okay, my PhD research is during 2010. I started my PhD 2010. So 2009 tu sebenarnya dah ada orang buat bottom ash replace as sand. And kalau kita tengok, kan tadi I cakap the lesser the thermal conductivity, sebenarnya the better in terms of the performance of insulation. So memang betul. So this has been studied by Kurama. Dia tukar bottom ash dengan sand, memang thermal conductivity tu makin lama makin rendah. Sebab the porous that produce inside the aggregate contributes to insulation. Okay, and back in 2013, Lim pun dia ada study, dia pakai POFA, pump oil fuel ash. Okay, tadi bottom ash, kalau kita tengok kat power generation, electricity, okay, yang jatuh kat bawah ni bottom ash, okay, yang dekat atas tu is actually POFA lah, top ash. So POFA ni pump oil lah, bottom ash ni daripada coal power plant. Sebab tu I combine agricultural waste dengan industrial waste into my aerated concrete. So this is what I did. So kalau kita tengok pun kat sini dia bagi tahulah apa tu thermal conductivity untuk POFA 20% dia makin reduce, tapi dia tak study sampai 30%. Yang ni maksudnya dia pakai zero, tak ada apa-apa waste, 0.65. Bila dia ukur with 10% POFA, I mean the thermal conductivity is reducing. So that's why when we studied, we think initial idea kita rasa oh betul benda ni boleh buat. Sebenarnya my PhD I change my topic after 1 year. So sometimes you buat jadi, sometimes you buat tak jadi. So kalau you nak buat yang terbaik, normally you will try and try and try, but you need to know there is a timeline. So like as for me, I started my PhD again after a year. So tak apalah, sebab the first year tu for me is I'm learning on my learning stage. So after second year, dah dapat idea benda ni, I terus buat and terus dapat idea awalan yang memang jadi by using kita panggil preliminary study lah. So what I did is that I'm using my preliminary study. Macam tadi kan kita dah dapat idea, oh bottom ash, fly ash ni boleh integrate. So kan at the same time you ni macam biasalah bila you become researcher, semua benda you nak try. So samalah, I also did the same thing. This one is expanded polystyrene, yang apa polystyrene tu? I'm using EPS, I mix with cement. I try to study dia punya behavior. At the same time, normal concrete ada, and this is the one bottom ash, the one that I did for my research. So I just mix around, I play, and I'll try to test. And fortunate enough, the result shows that the bottom ash, kalau you tengok kat sini, has the least thermal heat. Kalau you tengok surface temperature dia paling rendah. So I was like, that is how I started to do my research, by having preliminary study. So, bila I buat, I compare dengan normal concrete, I can see that, wow, there's about 2 degrees Celsius. Dekat Malaysia, 2 degrees is a lot. Kalau you tengok ceramic cement, it's very high. It's about, here, let's say it's about 40, we have to take during the peak hour kan. Now it's about 48, but the bottom ash is just about 42. So 48, 42 roughly is about 6 degrees, is a lot. So I think, there is a potential of I'm doing this research. So that's how I start off with my research lah. It shows that bottom ash has the least thermal effect. Then again, I started to study, bila you research kan, you buat lagi, and then you study in terms of dia punya chemical composition. And we have to know, like I mentioned to you, kalau untuk kekuatan concrete, silica and alumina is very important. So again, I look into the bottom ash, the silica is 42%, very high. POFA also very high as compared to normal portland cement. So I think, wow, there is a potential. And we can see here, the alumina silicate also is very high. And then again, when you look, you study banyak paper then, no wonder lah bottom ash dengan tadi kalau you tengok, it has a very least in terms of surface temperature, heat yang absorb paling rendah dekat bottom ash. So then again, I try to think, bila I baca kan, rupanya silica, alumina, ferrum dengan titanium ni, it has a reflective pigment. So maksudnya, the material that I created, it has reflective pigment, and it also have an insulation behavior. So I was like, I started to become happy lah. Lepas setahun you buat tak jadi, you tukar tajuk, you buat lagi, you dah nampak there is a green light in my research. So, you started to do, and you started to be, you're very ambitious lah. During this time, after 2 years kan, bila you down, you dah nampak you punya light, green light in front of you, you started to be happy. So, I'll try to start off doing lots of study. I'm doing lots of sample. It's about 120 samples. Buat jadi tak jadi apa kita semua try. And this is how I develop my mixing phase. Whereby I'm adding the POFA, the cement, the hydrated lime, the bottom ash, and then I add in with aluminium powder and superplasticizer. The good thing about aerated concrete, it acts like a muffin. Kalau you buat, you bancuh, you boleh nampak. Sebenarnya dia akan naik you bancuh 2/3, you letak 2/3, nanti dia akan naik. So 2/3 of the mold, and you can see that it will become like a muffin, and you will cut off. So you know, it shows that your material started to raise. Okay, sebab aerated concrete is like a foam concrete. There is a hole that is created, aerated, it being created inside. So this is how I develop, and there's a lot of study that I have to look into the aluminium percentage, the superplasticizer percentage, and from here it shows that okay, kalau kita tengok every time we do a research on material, we have to check the compressive strength. So memang of course control the strength is very high because it is not aerated. Okay, dia tak ada porous. But I compared with control sand and control bottom ash, it has quite similar performance. So as long as it's achievable, okay, for a normal non-load bearing wall, kita kena at least achieve 5 megapascal. So at least I'm achieving the standard requirement of UBBL. Okay, Uniform Building by Law, stating that to have a non-load bearing wall, you must have like at least 5 megapascal. So at least kita achieve that point, should be okay. Okay, some more, bila I add up, POFA is actually a long-term strength. So it is high strength at later age. So that's why pozzolanic punya behavior ni, dia create high strength after 40 days. So that's the reason I was like thinking, oh, the strength is going to get better and creating better lah. That's the reason why I think it's okay. So I did achieve at least 7 megapascal. And then again, I look into the thermal conductivity performance. Like I mentioned to you, when we talk about thermal insulation, it must have a lesser in terms of thermal conductivity, and control bottom ash shows that it has lesser thermal conductivity as compared to yang lain lah. So tu yang I tried to start with during the research. Okay, ni I went to MPOB to do this thermal conductivity testing. It follows ASTM C17797 standard, right? So this is my mixed proportion. Okay, again, the compressive strength that I get. Remember tadi kan I did mention to you, POFA, bila kita letak pozzolanic material, it will create high strength. So after 7 days, if I'm not mistaken, we check and after 21 days, okay, I check. It shows that 10% sebenarnya an optimum design for based on limb. Dia kata 10% is an optimum, but when I undergo my own research, I find out that 20 is actually the best optimum design. But then again, because I want to have a lower thermal conductivity, I'll choose 30 sebab dia still acceptable in terms of compressive strength. Okay. This is the density. Like I mentioned to you, the lower the density, the better. So this is lightweight, since my material is just roughly about 1.3 kilogram per meter cube. Okay. Again, this is study on a very technical aspect. I'm looking into the contribution on the strength, and it shows that it has a quite high void, but it's still acceptable for a very the void percentage, because kalau kita tengok absorption percentage, it must achieve, kalau it is a good concrete, it should have like less than 3%. POFA, it has 6, but it is considered acceptable because dia tak create kulat ke, okay, on that particular material. Right. So again, this is looking into the density. Okay, it has ranging in between 1002 to 1005. The compressive strength 5 megapascal. I'm looking into the lower thermal conductivity, which is 0.48, as compared to commercial is 0.3 to 0.5. Tapi again, commercial dia pakai high steam. So we try to ignore the high steam, and the porosity created is about 32% as compared to commercial is about 70. So it's still acceptable in our condition for material. And this is what my material is. You can see here, small hole were created, and how I define the 32% of porosity is by using micro intrusion porosity. I did the test in Japan. Okay, here this is in Japan. I'm looking into the interparticle pore and also intercluster pore. Actually, we can dig in lagi. Kita boleh belajar lagi. What does it mean by interparticle and intercluster? That is actually why there is a significant value on the thermal heat performance in terms of insulation, because there is a pore created in this material. Okay. If you can still remember, just now I did mention about aerated concrete, whereby the aerated concrete, it produces ettringite. So ettringite is the one that create the strength. And again, if you can see aerated concrete here, this is what I call as ettringite. Kalau kita tengok kat sini, it is like a needle shape. Okay, ettringite ni yang akan produce what we call as tobamorite formation, and tobamorite formation ni lah yang akan create a strength in between the structure. Okay, ini normal commercial, and I compared with the one that I did, and I can see that my material is slightly different, whereby it created a hexagonal crystal, and this hexagonal crystal ni is actually calcium silicate it is a hydration process, and kita ada boleh nampak ada cotton shape. So this cotton shape is actually calcium silicate hydride gel, which will cause a pozzolanic reaction later on. So sorry, it's very technical, but this is how, kalau kita tengok dalam microstructure, okay, if you look into the micro scale, this is actually what you can see inside the tadi yang concrete biasa tu. You zoom in, there's a lot of things that you can discover. So it's very nice if you can undergo this study lah, sebab kita nak kena tengok in terms of strength, in terms of insulation that created. Okay. Then again, I'm looking into the SRD, X-ray diffraction analysis. How the behavior of this strength created 35 megapascal compressive strength. So how it created is I have to undergo into the micro scale, and looking into that, rupanya dalam material itself, it has pollandite, berlinite, calcite, and kuzalite. So CSH also being created. Calcite also is quite a lot, and that's the reason why the strength is there. Okay. This is regarding the strength as well, but I have to skip this. I think it's very technical. All right, but this is the thing that I'm going to show you as an architect students. This is how I studied in terms of thermal behavior, whereby I do have pyranometer. So is there anyone knows what is pyranometer? Well, guys, boleh siapa-siapa tell me what is actually pyranometer? Semua ada lagi tak tu? No.
Anyone, students? Just wow, guess.
Well, guys, come on. Christine Young, maybe. Can you tell me what is actually pyranometer? You have Google. You can Google. Christine? Maybe Shahrudin ke? What is actually pyranometer? Ada lagi tak tu?
Ada measuring.
Okay, measuring solar. Core. Is it core?
It's core.
Core. All right,
Yeah.
good core. Measuring solar. Okay. What skills that they're using? Measuring solar. Have you? Is there any one of you that have been used pyranometer before? Nope. Kwa, nope. Arifan, no, never. Belinda, okay. All right. So this pyranometer is actually yang akan sukat solar radiation. Okay, correct. What Koa meant, solar. Okay, solar radiation. So, how I mentioned that solar reflectance amount is actually we calculate based on pyranometer, right? So I'm using pyranometer to get to know what is actually the critical solar on that day. And then I mix around with 10% replacement of POPA, 20% replacement of POPA, and 30%. All right. And from there, I'm using the data logger to actually check the surface temperature in and out. So that is how I scale my model. Okay, and if you can see, the higher the numbers of POFA, actually the darker the shades. And looking into the albedo, actually is not good since the reflectance is more on the lighter color. But then again, we are looking into different aspect, okay, because we have to know the behavior of heat transfer. Like I mentioned to you, we have to know in terms of thermal mass performance. So I'm measuring again after I identify based on 0, 10, 20, and 30 what is actually the optimum value. And then I've been comparing again with red brick, with control bottom ash, control sand, and also aerated concrete. So from here, I'll scale back. I did another study which I studied in terms of, I think, almost a mine, in order to check what is actually the critical maximum point of solar radiation. Sebab bila you nak buat research, you need to know the most hottest time. Okay, kita kena ambil yang paling peak, paling panas. So that's the reason why I have to check in 1 month time. And based on this 1 month time, I choose one day which has the highest solar radiation on that particular day. Okay, so this is how I did for my study. Okay, whereby I'll check the reflectance. Okay, I'll check the incident solar radiation. Okay, by using pyranometer. I also have the Hobo data logger just to check the humidity on that particular day, because we want to insert the Q convectional, the Q conduction, the heat of conduction and heat of convection. We have to know the humidity. Okay, and I need to know the time lag. Okay, just now, tadi kan saya dah mention, every time heat absorb dekat dalam material, dia akan create heat mass. Okay, heat mass ni akan simpan dan akan lepaskan haba. So, berapa lama dia simpan dan berapa lama dia lepas, we call it as time lag. So, it's very important for you to study the time lag as well. So, that's why you need to know how long it started to absorb and how long it started to release. That is what we call as time lag. So these are the things that I studied. Okay, after 1 month I studied, I find out that the maximum peak is actually on 11 November. Alamak, bukan 11 okay, 11 November 2012. Okay, this is actually the peak point. And if you can see, like I mentioned just now, the solar radiation, kalau kita tengok, is actually in between pukul 1, dia depends on the day lah, but basically it started from 1:30 to 3:45 lah. Okay, and then kita tengok balik kepada kita punya ambient temperature. So from there, I'll zoom in and I studied again the performance on the solar radiation and also the outdoor temperature, surface temperature, and indoor surface temperature. I did compare and I look into how the performance of thermal in and out, the heat convection and conduction. And from the result that I got, okay, it shows that 30%, okay, you can see here, the time lag is longer. So depends, if you're looking into a very good thermal insulation, we want to have a high time lag. But if you're looking into a very good thermal performance yang serap haba cepat dan release haba cepat, we are looking into the very less thermal time lag. But then again, kita kena tengok macam-macam possibility sebab even 0% it has a lesser time lag, tapi sebab kita nak tengok the behavior of insulation, okay, kita tengok juga heat of convection, conduction. So it shows that yes, correct, 30% has a very high thermal insulation, but then again looking into the reflectance, okay, kalau kita tengok kat sini, heat of convection ni maksudnya dia absorb and dia release balik that I mentioned to you. Bottom ash, okay, sekejap okay, you can see here, kalau kita, ini thermal camera I pakai thermal camera, I try to check from 0% replacement of profile sampai 30% profile. Kita tengok pukul 10, profile ni lambat, 30% ni dia lambat serap haba. Okay, pukul 2, tengok pukul 5 dia dah release back. So this is actually a good thing of having this bottom ash whereby dia serap haba lambat, pukul 2 dia serap, pukul 5 dia dah lepaskan. Okay, so this is the reason why it is good in terms of heat of convection, tapi time lag pun dia very good sebab dia simpan haba lama dekat dalam material. Okay, so this is what I call as stored the heat, and it started to release also very fast. Okay, you can see here, heat of conduction, dia started to release, kalau untuk 30%, dia on top. So kalau positive value, it release the heat faster as compared to 10% heat. Okay, so this is how it behaves. Alright, so that is the comparison of my study. Okay, when we look into the performance of heat of conduction, dia serap haba. Kalau kita tengok commercial ni, dia serap sama je, lebih kurang. I mean, they started to absorb the heat around 11 ni sebenarnya dia dah, material ni dah start to absorb. Tapi kalau kita tengok aerated concrete, normal commercial, dia lepaskan haba dalam pukul 10 ni, nampak tak dia dah lepaskan haba. Tapi kalau kita tengok 30%, dia serap, lepas tu dia dah lepas, dia dah positive value. So it shows that bottom ash ni dia simpan haba tapi dia tak simpan haba terlalu lama. Time lag dia simpan banyak tapi dia lepaskan pun cepat. So that's the reason why 30% I can say is the best, even though they have a very minimum in terms of strength and very minimum in terms of strength value lah. Tadi kalau kita tengok strength dia 5 je, tapi at least they achieve UVBL value. Right? So that is how I come up with my research, and I show that, and it shows lah that 30% it does improve. Dia dapat kurangkan 2 degrees Celsius. If you can see here, dia punya comparison degree is about 2%. Tengok pukul 5 dia dah started to release the heat. Okay, dia serap dan dia release as compared to normal aerated by sand dengan by fully bottom ash. So again, okay, I can conclude that my material, dia punya thermal insulation tu very good, tapi it depends sebab kalau kita panas, thermal insulation yang terlalu tinggi pun tak berapa bagus. Tapi yang very good thing is that it absorb the heat fast and it release back the heat also very fast. Sebab tu again, bottom ash ni is very critical to be used, to be utilized, since it has a very good in terms of insulation property. Tapi again, kalau tengok tadi strength dia not really promising, dia tak boleh nak achieve macam normal cement pakai sand, sebab normal cement pakai sand dia boleh achieve up to 40 megapascal, 10, 40 depends. Tapi kita hanya achieve 5, cukup sekadar non-load bearing wall. But then again, it improve in terms of urban heat island climate, whereby kita nak dia serap dan dia lepas haba pun very sebab saya tak tengok in terms of very whole scale, I'm looking into the small scale, but looking into the small scale pun dia tak terlalu simpan the heat dekat dalam human, and it good in terms of giving the human comfortability dalam bangunan. Sebab that is the most important. Kita tak nak haba tu tersimpan dalam bangunan, kita nak haba tu dilepaskan. Okay. So that what I get from my research. I mean, in terms of performance, it's very good, but in terms of strength, it's not really. That's the reason why research is there. Okay, we have to always improve, looking into the aspect of material. What kind of material actually can improve the strength, right? So I can say that my research here is double insulate. But then again, we have to improve lah by time. So that's it. Okay. Recommendation again. I'm looking into the air circulation later on. All right. So that's it. Dr. PC.
Okay,
What
thank you very much, Dr. Eeydzah.
You're welcome.
Okay,
Hope it helps. Yeah.
yeah, it think very interesting, and I'm hope that student really learn and understands about one of the sustainable materials that they could apply other than just using those conventionals on the market itself. So because this is one of our so-called local inventions and which is quite widely studied in Malaysia context. Am I right? I remember. Yeah, because I know like POFA bottom ash fly ash is some things that using the palm oil that we have produced quite a lot in Malaysia. Hence, we have the potentials for us, I mean, in local context, to use these materials to produce some kind of the sustainable materials for the construction industry. Okay, now I open up the sessions for students. Any questions from the students? So you may try to ask Dr. Eeydzah while she is still here. Please grab her, okay? Anything that you wish to ask about the materials, the sustainable materials? Okay, well, maybe about design, okay, about the products, or maybe some things about applications that you doubt and you wish to know. So maybe you can ask Dr. Eeydzah. If you are shy, you can type in the chat box here.
Please. I'm
Yeah,
happy.
please ask. Yeah. Dr. Eeydzah is very helpful.
Hopefully you guys understand. Did you guys understand? It's quite technical. No, but I'm not so sure. Dr. PC, if I may add just 5 more slides.
Okay, sure.
Okay,
All right, sure.
while
Please,
waiting
please.
for them to type, hopefully they are typing questions. Okay. I'll just want to show you because last week, like I mentioned, we just launched a strategic construction 4.0 strategic plan. And I think as a master students, it's very important for me to expose to you guys what the initiative that we are focusing into. Okay. So yes, again, if you can see here in our construction strategic plan, we are focusing towards the technology. Okay, but you have to know technology change. But the thing here, we did put advanced building material. So the thing that I just teach you guys, I just share the research that I did is actually a part of strategic plan, whereby we have to focus on the advanced building material. So it's a part of a national agenda. Okay, but then again, we are looking into the prefabricated. Okay, like Dr. PC, we are looking into hors d'oeuvres. So hors d'oeuvres is a part of prefabrication. Yes, correct. It's a part of the national agenda that we are looking into. We are also focusing on the 3D printing. So lots of companies now, they are exploring on the 3D printing, because as we know, concrete, it has a quite later strength. I mean, it hardened almost, at least a day. So to have a 3D printing, at least they can harden in 3 to 4 hours. So they are trying to study in terms of polymer. But then again, polymer is quite expensive. So they are still undergo the study on what kind of material that is possible to have for the 3D printing. We're also looking into the autonomous construction, okay, whereby we are looking into robotics that do jobs on site. We are looking into the integration of AR and VR. And the most part that I want to focus here is actually BIM, Building Information Modeling. So again, if you can see, World Economic Forum, these are the element that they integrate for IR4, whereby building information modeling is there. What I'm trying to focus today is that after actually my research now, I'm more focusing on the integration, what's next. okay, I already come up with the idea of thermal insulation for brick. How I want to check the performance is actually by creating the energy management. So Dr. PC knows about this. Dr. PC is a part of the team. We have master students that work on this. From Beam, okay, we are using Rabbit as a model. We can actually have the idea of integrating the performance, the thermal performance. So basically, okay, this is a part of how the simulation is being conducted, but I'll just want to show a part of it whereby we can later, from the idea of thermal performance, the integration, we can actually get the idea of how the simulation is being performed. So the integration of Beam with Revit, and we were going to put in the thermal conductivity, the thermal performance that we got from our study, and we're going to combine with the energy management, and that is the beautiful of this Beam, whereby we can have the simulation idea on the thermal performance that we're going to perform for our building. So I'll just add in what is actually the continuous program a continuous project that we can do. Research is actually to understand the material part, and now we are looking into the simulation on the application part. So it's good for masters. If you want to continue for PhD, try to think of on this kind of study. Am I right, Dr. PC?
Yeah, you are right, Dr. Eeydzah. Okay, because the potential and the future is there. Okay, so about the sustainabilities, about BIMs and so forth. Okay, students, anyone? No
Okay.
questions?
Please shoot me 1 or 2 questions. At least I know that a part of you knows the lecture, right?
Yeah. Maybe I ask first. Okay, all students still think about that. Okay, Dr. Eeydzah, just wondering, because last time I still remember participated in the competitions, right? So the use of bottom ash and the profile, first question, silly questions. What's the differences between these two? Bottom fly ash and profile itself. Is it the same thing or different thing?
It's different thing. Like I mentioned here, okay, when we generate okay, tak kisah lah energy. If we generate just now, when we talk about bottom end, we're talking about coal. Okay, kita pakai coal and pembakaran dekat factory tu. The combustion that happen in the factory, you will create two kind of ashes, which is the top ash and the bottom ash. So POFA, palm oil fuel ash, is at the palm oil. So sama juga, palm oil also they will create top ash and bottom ash. So the POFA is actually from the top ash. Okay, the bottom ash is actually, the bottom ash is actually from the bottom. Maknanya pembakaran yang lengkap, it will produce top ash. So these ashes actually when the combustion, high combustion heat the either palm oil or coal, it will create ashes that going to fly up. So the one that fly up it is called top ash. The one that going to settle down, okay, they bakar and they will going to, the burst, it will create like so-called bottom ash. That's why bottom ash is like more like a stone kind of material, but the top ash is more on like a very, it's like ashes. So that's different. Ashes, top ash and bottom ash. In terms of performance pun berbeza, because top ash, it will create, like the performance is even better in terms of the strength. But the bottom ash, it has like just like an aggregate structure whereby dia tak banyak in terms of characteristic in terms of improving the strength. Tak. Dia tak ada strength sangat. Sebab aluminium and silica ada tapi dia tak halus.
I see. So it's like the ideas of the petrol, am I right? It's like the pembakaran petrol yang atas tu kapal terbang, yang bawah tu diesel, which is for the truck and so forth. So the idea is similar. Am I right?
Yeah.
I see.
Yeah,
So
correct.
just wondering, because how easy, we get the POFA and the bottom ash from the current industry kilang. Is it very easy or it's very difficult because not much people using that and so forth? How about this in of this perspective?
Sebenarnya, if you look into the availability is a lot. Okay, I was quite
A lot.
surprised sebab a lot. Sebenarnya banyak smuggle. If you can see, our clay brick, sekarang ni clay brick kita dah improve tau, sejuk. Sebenarnya, our batu merah tu, clay brick tu, they already add on, they already use bottom ash and acid inside their ingredient. Tapi they don't
I see.
sebab exposing it, they're gonna cost a lot sebab bottom ash ni dikatakan hazardous. So Jabatan Alam Sekitar is the one that control the usage of this bottom ash, and it's still a problem. This 2017, this issue has been brought out. Diorang dah create satu technical team bawah SIRIM, bawah CITB untuk study pasal bottom ash. But still, ada banyak isu lah. Okay, they
I see.
bring this and an issue. And CITB last time already called our team to team up again and cuba bantu sebab kita sebenarnya benda ni is very good. Is abundance. A lot. Dia adalah bahan terbuang yang orang buang kat landfill. Tapi the issue is kita punya alam sekitar yang protecting tak kasih guna. Tapi sebenarnya bagus. Because when we look into it, diorang panggil content of hazardous ni, sebenarnya mercury content semua ada tapi very small. Dia lepas standard. Tapi lepas in terms of alam sekitar.
I
So we're
see.
still
Means
studying it.
because of the policy wise, so that's why not much people using these materials, am I right? Or just wondering, is that okay, for example, these materials, sustainable materials, basically where usually we can get, like kilang ke atau incinerators ke atau mana-mana? Is that easy? Every state ada ke atau macam mana?
Okay, kalau kita tengok kita punya energy power plant generation dekat Malaysia ni ada 7. So Lafarge sebenarnya diorang dah control. Sebab diorang nampak sebab tu blended cement, sebab tu cement kita dikatakan blended cement. And Lafarge sebenarnya dah ambil. And diorang dah nampak possibility sebab tu diorang ambil dan diorang letak dalam diorang dah ambil, diorang tak kasi orang luar beli.
Okay.
Power plant kita memang Lafarge dah ada agreement for 30 years yang memang this top ash diorang akan pakai untuk blended cement. Sebab dia improve, it is quite good. Sebab tu kita panggil waste to wealth generation.
Yeah, correct.
Because it creates money. Tapi itulah kita kena tahulah, all this party dia ada yang
Faham.
the reason why it is still a problem. I already give this issue to KSU. Last time I managed to see KSU bahagian dasar. That's why they are still keep on studying the performance sebab ada yang agreed, ada yang tak agreed. Kalau if you look into UK, bila this bottom ash, kita panggil SS, solidified, dan kita dah stabilize and solidified, by right kita dah boleh guna. Sebab bila bottom ash campur dengan simen ke, campur dengan pasir ke, dia dah dipanggil solidification and stabilize and solidified. So sebenarnya dia dah boleh digunakan untuk construction material. Sebab tu blended ash, maknanya top ash lepas untuk Lafarge tapi conquer satu Malaysia. Yang problem sekarang bottom ash. Tapi sebenarnya bottom ash ada isu kalau kita tengok balik kepada dia punya hazardous dengan itulah konsep solidified and stabilize.
So it's no longer hazardous for the humans and the environment anymore, right? Kalau dia dah solidify.
Correct.
Okay, so just wondering, okay, because this is from the agriculture, right? Is it like the whole trees of the palm oil or pokok daun ke, trunk ke, or any parts of it?
Okay, sebenarnya kalau kita tengok the beauty of this research, sebenarnya palm oil tu setiap komponen dia it has the thing can change into material. Like last time, you can see, we have trunk. We have the trunk that can be used as a part of the material untuk menggantikan kayu. We have buah dia sebenarnya kalau kita bakar, kita boleh ganti dia sabut kelapa. Sorry, dia macam sabut kelapa, it will behave like sabut kelapa. So sabut kelapa sawit ni, dia pun kalau kita rendam, kita apa, ada a few treatment lah we have to do. Dia boleh gantikan sebagai insulation. So so dalam kita punya aggregate. So it's very beauty sebab setiap terang, dia punya buah, dia punya fiber, kita boleh guna balik untuk building materials.
Yes, yes. It's like the whole tree itself can be used for competitions, like what we have the last time, the competitions, the sustainable house competitions. All right. So, just wondering, is there any parts of, like, for example, kalau kita community and of, you know, because the kilang, you said only 7 kilang around Malaysia, is there any parts of the trees, let's say some penduduk kampung ke, they can burn or they can process part of it them by themselves, then eventually they can use like the bottom ash ke, fly ash ke itself to build the house and so forth. I just means that applications wise lah. Is there any possible, or they have to go through a very stringent and very strict kind of the process, only you can use the product? Is there any possible for community to do so? Just asking.
Okay, it's quite interesting question. By right sebenarnya, kita lah, I mean, we have the knowledge. So sebenarnya macam kita transfer. So if you can have the knowledge, kalau kita banyak membaca, sebenarnya we can help the community around us. Okay, we have to study. Okay, rupanya branches, contohlah palm oil itself. Sebenarnya kita boleh buat sendiri, tapi we have to educate. Oh, because of this agriculture waste, kalau kita, dia akan rapuh, dia akan apa? Dia akan kering. So macam mana nak stabilize? We still call it as stabilize the material. We have to educate them. Oh, you kena rendam, you kena rendam dengan sodium oxide untuk kekalkan dia punya property, and baru kita teach them, okay, how you going to process this for your material, sebab you have to know kalau kita guna secara langsung tak boleh, so you can process dulu all this material into valuable lah, so you can faham konsep teori, so you kena belajar, you kena baca, banyak membaca macam terang. It can still be used for atap, for example kan, macam branches dia, but then you have to help them, okay, you kena buat certain treatment dulu before you use that. So it can be used, dia tak memerlukan a very critical process, tapi again the knowledge must be transferred to community.
Okay, thanks. Because architecture, usually we were trying to relate to community, see whether how we can benefit the community, For example, we can ask them, partly be part of the process of the processing. Hence, at the end, maybe the final building itself, the whole building have some benefit. How to say? It's like participated. Okay, they have the sense of participations by the community themselves. Okay, we have one question over here. Fadli, is there any real project that already used this bottom ash product? How was the performance so far during day and night?
Okay, so bottom ash like I mentioned, clay brick diorang memang dah pakai, tapi this kilang diorang pakai, diorang senyap je, diorang tak expose. So because they see this as a waste to wealth, okay? But there is a restriction in between our government agencies, like Jabatan Alam Sekitar, they still keep this as a hazardous waste. So kalau you cakap black market tu ada. Okay, there is a real project, and the performance is there because they claim, I cannot reveal the factory name because by illegal they still use this, but they claim that this sejuk. Okay, the building, the house that they built is cool. So kalau you pun boleh beli bottom clay brick sekarang, sebab dia memang is ni lah, is it has the performance improvement.
Okay. Any other questions, students? I think this is a very interesting topic that you all can ponder on. Yeah, sustainable material itself. Okay, it's not just come from the market itself. Probably you can propose, in the design, hence it will benefit the local, as well. Okay, this is part of our architect's roles as well. Okay, if no questions, last chance. No.
Come on, shoot me one more question.
Come on, guys.
Come on.
Yeah, Doctor. I'm Carl.
Hi, talk.
Yeah, Kwang Wu. So actually, I just want to ask that is maybe about the technical question a bit.
Okay, sure.
For the normal cement concrete is the example is the 30 grade.
Yeah.
Then for this one, because just now you say that is maybe it cannot compare with the cement concrete. So consider that this one is a 29 grade or what?
Okay, thanks, Carl, for your question. Okay,
Yeah.
normal concrete grade, looking into the Europe nowadays is 37, 37.
Yeah.
All right. Okay. Looking into this, because just now, like I mentioned, we try to, as for now, we just tackle the non-load bearing. So it's not for load bearing. So load bearing, yes, we are talking about 37 megapascal. But as for non-load bearing, at least 5 megapascal achieve standard limit of UBBL, Uniform Building Bylaw. So because we try to develop just the thermal performance for the materials of bahagian interior, bahagian exterior. So kita aim untuk try to make sure the heat transfers, but tropical climate is very hot, so we try to plan the thermal performance that can improve in terms of exterior building. So kita tengok daripada segi luar kawasan rumah tu sendiri. Okay, we try to reflect. We try to develop material that can reflect.
So sorry, another one is means that is it like that we need to add more the structure bar or less the structure bar?
Okay, if it's possible, as already have framing, contohlah building, we have building. This building already have the frame. We have the column, the beam, the column. And then along the way, we can just, that's why when you design, you will say that is a brick wall. So this act like a brick wall.
Yeah, okay. Okay, thanks.
Thank you. Thanks for the question.
Yeah.
Okay, we have another questions. Thank you. Now, we have another question from Anissa. Is there any limitations on structural strengths of this aerated concrete as compared to other materials?
All right, thanks. Yes, like I mentioned to you just now, thanks for the question. Okay, kalau kita tengok in terms of strength, we have to achieve at least 30 to 37. Aerated concrete, currently, kalau we are talking about interlocking block system. Okay, now it's different. Tadi yang I mentioned 30 to 37 is a normal load bearing. Okay, but now kalau kita tengok rumah, diorang dah pakai interlocking block system. So interlocking block system, the block itself can cater the strength. Maknanya tak payah ada column, tak payah ada beam pun dah boleh, the strength is there. So interlocking block system, at least we have to cater 7 megapascal to 11. So kalau nak pakai aerated concrete ni masih boleh, just that kita kena pakai instead of 30% tadi, kita pakai 20% ke? Sebab tadi 20% dia boleh improve the strength. And maybe we have to add more kind of material. Mungkin pasir kena, sebab pasir ni dia akan improvekan strength. So mungkin pasir with bottom ash, with 20% at least so far, then it can improve it can achieve. Sebab 5 megapascal and 7 megapascal is not that much. So kita boleh achieve for so-called interlocking block system. Okay, it can be used.
Okay, Anissa. Hopefully, Dr. Eeydzah answer your questions. Okay, guys. Any more questions?
Any more questions, guys?
Okay. Questions. Once again, thank you very much, Dr. Eeydzah, for giving a very interesting and informative kinds of the input lectures today for the students. At least they understands about one type of the sustainable material which is widely studied in Malaysia. Yeah. Okay. So okay, sure.
If I may just share with you guys,
All right.
please check the MyCrest, okay? Because just now I did mention about MyCrest kan?
Yeah.
Point. Sebab dalam MyCrest, there is a part of element on sustainability.
My Crest. So guys, maybe you when you're doing your design, you can check on Crest. Okay.
Okay. Okay, if you can see here,
Yes.
sustainability, okay, kalau dia tengok, dia ada nak recycle content. So nowadays, kalau kita ada at least recycle content about 50 materials, so you can get a lot, I mean the scoring point over here. So every time you guys build as architect, okay, you kena tahulah all this recycle content because every time you design, you have to make sure you fulfill all the characteristics inside Minecraft. So Minecraft is quite huge, quite big. Okay, they're looking into pre-design, infrastructure, sequestration. Okay, if I may share, kat mana share Minecraft sekejap. If I may share, alamak. I think it's not here. If I may share the Minecraft info in general, but I think I no longer here kot, dah tak ada. Okay, it's okay. But again, you guys can look into this lah. Maknanya because Minecraft memang every single material ke apa yang kita design, you have to fulfill. Why I'm looking into the thermal comfort, I mean the insulation, because you know, diorang pun ada lowering point of embodied carbon. Green products, if you use 40 to 49% of green products scoring, kalau 50 to 59 you can get 2 marks. If you use all those sources materials, okay, they're looking into the IBS scoring, the QLASIC, the carbon emission, if you can show the carbon emission, the waste material, okay, waste management, you are actually giving the point for Minecraft. And I heard Minecraft is going to be a compulsory because they're going to put it under the certification green procurement.
Yeah. Green
So,
procurement. Yeah.
Yeah, green
Yes.
procurement. It's a compulsory. I think when you guys always study on sustainability, try to find out this green tools. So because it's gonna put, I mean, they're gonna put this as one of the requirement in our construction industry. Thank
Okay.
you.
Thank you very much for sharing. I think this is also very something additional. Yeah, Minecraft is like GBI, one of the green rating tools. Okay, developed by CIDB. Okay, so in Malaysia there are a lot of the green rating tools. So I think it's good for you guys to understand each of them. Okay, at least you know basic. Okay, of that. So since Dr. Eeydzah have already introduced part of it, probably you can further studies on that. Okay, and apply or maybe understands when you're trying to design for sustainable building later, so do check on these criteria so that see whether it's fulfilling your baselines of your green buildings or not. Okay, yeah. All right, so thank you very much, Dr. Eeydzah. Yeah, for giving us the input lecture today. So hopefully in futures we could have another input lecture from you as well. Okay, maybe about Beam Good or maybe others.
Yeah, hopefully I can share it again. So nice to meet you guys. Thank you so much, Dr. PC, for inviting me. Okay, guys, if you guys have questions, you can just always go to ResearchGate, okay, or LinkedIn. You just type my name and I'll try to interact you as much as I can.
Okay. Yeah. Thank you very much, Dr. Eeydzah. Right. Have a nice day. Okay.
You too.
Thank you.
Bye.
Okay. See you. Bye-bye.
Bye.
Okay. Thank you. Okay, students, you may proceed with your respective work-based master or panels. Okay, for the table create later. Okay. Thank you very much. Okay. Bye-bye. See you.